Have you ever stared at a handful of numbers and wondered, could something as basic as arithmetic actually build a universe?
It sounds completely wild, but that's exactly the claim behind infinite finite cosmology. I'm genuinely excited to dig into this. And joining me is, and today we'll ask, what if the universe starts not with space, not with fields, but just with the rule n+1?
Here's our promise. We'll unpack what it means for arithmetic, not geometry, to be the root of existence, and show how this radical idea tries to explain space, matter, and even entropy.
We'll walk through the basic postulate succession, how that simple operation explodes into complexity, why the continuum might not be so fundamental, and how the theory claims to compress the whole universe into a single equation. Let's get started with the basic building block, the successor field.
So the entire framework kicks off with this operation. Sukin equals n+1. It's just counting, right? But apparently, this simple process has teeth.
Exactly what's fascinating is that it doesn't assume anything about space or time. There's just an infinite string of numbers, no geometry, no shapes, just pure succession. And that's supposed to be enough to get the ball rolling.
It's honestly a bit mind-bending. The claim is, if you take this field and project it modulo 4, these 4 residues start to differentiate. That's the first sign of structure, like the seeds of rotation and direction.
Right. And that's a huge shift. Instead of assuming the universe is smooth and continuous, this approach says discreteness, actual steps come first. Geometry has to emerge out of arithmetic, not the other way around.
This residue structure is where it gets spicy. Modulo 4 splits the field into 4 types, and apparently, this is where the 1 plus 3-dimensional framework comes from 1 active direction and 3 inert ones.
That totally surprised me. The framework interprets the active rail as time and the other 3 as space. So, dimensionality isn't just assumed it's forced by the arithmetic. It feels like watching time and space appear out of thin air.
And the cyclic nature of mod 4 means the residues rotate. They're not static. That rotation encodes a kind of proto-geometry. We're not talking about shapes yet, but the roots of curvature and torsion are already wired in.
It's kind of poetic before you ever get to atoms or galaxies. You've got this minimal arithmetic seed already suggesting movement, cycles, and eventually the fabric of space-time itself.
Now, this is where most cosmology fans do a double take. How does matter show up in this picture?
Here's the wild part. The theory introduces a refinement threshold, specifically crossing 4 pi, where curvature and torsion lock together to form stable knots. These knots aren't metaphorical, they're the framework's version of protons, electrons, and neutrinos.
So, matter isn't something that's just plopped in. It emerges from arithmetic when the system gets complex enough. That's where you get the 3 stable particle types. The conservation laws, they're all encoded at this stage.
I love how that ties back to entropy too. As soon as you project everything down to a finite domain, you lose information that loss is interpreted as entropy. So even the universe's tendency toward disorder is an arithmetic effect.
That actually reminds me this framework positions itself as finishing something Brouwer and the constructivists started over a century ago. They doubted the continuum, but didn't have the tools to replace it.
Yeah, Brouwer thought that math should be built step by step, not just assumed as a smooth whole. But he didn't have the successor field or the idea of residue cycles. That's where infinite finite cosmology claims to fill the gap with actual mechanism, not just philosophy.
And then it goes one further with the compression claim, that this is the shortest possible description of the universe's regularities. If someone finds a shorter, more fundamental algorithm that works, it's game over for this framework.
Exactly. It's presented as a candidate, not a dogma. It can be tested, falsified, and compared against other models. The challenge is out there. Can you beat this with fewer bits or steps?
Before we wrap up, I want to make this clear. This isn't just a numerology trick. It doesn't decorate math with physics language. It tries to show how minimal arithmetic machinery gives you everything else.
What's refreshing is that it doesn't demand belief. It asks for a direct comparison. How many primitive moves does your theory need? And it puts its predictions on the table, open to being proven wrong if the universe doesn't cooperate.
Plus, everything in the book is ultimately a refinement or projection from the arithmetic seed. Geometry, matter, even observer frames, They're not added ingredients, but consequences of the substrate.
If you want a taste of the big questions, later volumes take this machinery into evolution, galactic structure, and even the Riemann hypothesis. But it all circles back to, how much can you get from n+1?
So, 3 big takeaways for today. First, the entire universe might arise from the barest arithmetic just succession and residue cycles.
Second, geometry and matter aren't assumed. They're emergent, locked in by how arithmetic differentiates and refines itself.
And third, this framework is a bold compression claim. It's designed to be the shortest, most falsifiable blueprint of our universe, not just another story.
If you're curious, your next step is simple. Try to write down your own universe-generating rule in fewer steps. Or check out the framework's predictions and see how they hold up as new data comes in.
Thanks for listening. Keep questioning the obvious. And remember, sometimes the deepest mysteries begin with the simplest rules.